Hello, this is Sudhakar Maparthi. Today we're going to talk about VPC subnetting, and how we can divide the network into subnets and address blocks. So some basics here. This is the video that we have seen before. So you can have any number of VPCs in your AWS account, and each VPC will have a bunch of subnets, and in these subnets you will put your database servers, web servers, etc., etc. That's the high level. But if you want to understand the relationships with respect to VPC, you can watch this video. But I'm just going to refer to this right now with respect to a VPC subnetting. So let me open this sample VPC. Here we have a VPC with certain CIDR blocks. Come on, what's happening? All right, let me exit page. Wait. Something is happening here. Okay, let me restart. Exit. Oops. Let's log in back again. Okay, I lost connection. Sorry about that. Okay, let's get in my projects. VPC. Launch. So you get to this project. If you are registered at skillbanc and if you are working with us, then you will get access to all these things. So this is how you get to that particular project, VPC project. Okay. So we open that, and then this VPC, we have defined two IPv4 CIDR blocks, and this is the naming convention, this is the notation, and we're going to analyze what this notation is and then what are the intricacies in this. This is /24 is basically tells us that how many bits are common in this subnet. This is one subnet. This is another subnet. There are two subnets that we have defined, and the 24 bits are common for every IP address within this. So let's open this one, second one, and then show some IP address examples. So if I have to put some IP addresses, so this is how I'm going to do this. So as you could see, 172.30.2 should be common. Why? because we said 24 bits will be common. Number of common bits in the IPv4 address will be 24. This is the decimal notation that we are showing. Slash 24 means 24 bits will be common. 24 means 3 blocks. Each one is 8 bits. 172 we write in binary 8 bits. 30 in binary 8 bits. Number 2 also in 8 bits. So these bits would be common. Those are 24 bits. So what you are left with? You are left with another 256. Out of which max number of allowed host addresses will be 254, because I can put those many number of web servers or databases or whatnot, whatever machines, and I can assign an IPv4 address for each of these machines. So in this subnet 172.32.0/24, I can have all these devices up to a maximum of 254. So this grid can have maximum 254, and of which this prefix would be exactly the same. So let's take a look at another one. So your goal is to create your own VPC and then create your subnets and mention how many bits you are interested and in that subnet. So I can create another subnet. I can create whatever I want. 168, 20, 250, 222, 0 slash. So maybe I can say, instead of, I can say 00, and then I say 60. So in this, how many are possible? 256, 254, 256 multiplied by 256 max addresses are possible, and of which you will have this would be common for every address. So if I have to write some samples on this, so I'll just go in there and then I can assign the IP addresses for each one of these. I'm just creating these objects so that you have access to it, and then you can create your own. I'm just making these objects by changing certain things, but keeping that first two first 18 bits, in this case 168.20, as the same. So that's the whole idea here. What I want to really emphasize is you have 16 bits should be common in this subnet. Number of common bits in this IP4 address would be 16, obviously. So whatever that /16, it will be there. So an exercise would be, just how many you will have in this case? 254 for addresses for the here in this section, and then 254 max in here. So 254 multiplied by 254. So whatever that number is, we'll have to put it there. Okay, I think that's all I have for today. It's kind of a working video. So we had some problem with the internet, and then so I had to log out and all that. But I'm not going to edit this and right now. My goal for these videos, at least in the initial stages, is to just make it as quickly as possible. And then later I'm going to edit these things and make it concise and then publish a crisp and high quality video. So bear with me. And if you like these kind of videos and explaining little things, concepts, using these kind of C1C2 diagrams and creating those models into in skillbanc app, and then creating these objects and filling these kind of little details, you just only have to do a couple of times, no big deal. All these are very complex abstract concepts, but when you divide into small pieces like this, it will be pretty straightforward. So here, what is the big deal? There's a notation here, and then there is some prefix common thing going on, and then how many are allowed. There's a reason why I keep telling, here 254 or instead of 256. 2 to the power of 8 is 256. So what happens to those two addresses? Those two addresses, one would be used for broadcasting, the all ones. Okay, once 172.30.125.255 will be used for broadcasting, and .0 would be used for identifying the subnet. Okay, so if I have to draw, so you have a network, and you have other networks. Okay, every network needs to be identified. How will you identify that network? Using that 0 address. In this case, 172.130.125.0. And let's say you want to broadcast to this, you want to inform to this network, how will you broadcast? On what address you will broadcast. So you will broadcast on that 255 address, 172.30.125.255. That's the address you will use to broadcast. So two addresses, one for broadcasting and one for identifying the network itself will be used. Those two addresses will be used. The rest will be available for hosting our web servers, database servers, whatever EC2 instances. Anyway, thanks for your patience, and I appreciate. And if you like these kind of things, please get in touch and then subscribe. Take it easy. Bye.